And welcome back to the Cracking FAANG YouTube channel. Today we're going to be solving Leetcode problem number 3, longest substring without repeating characters. Before we get into the video, if you guys enjoy this kind of content, please like and leave a comment on the video. It helps me out a lot with the YouTube algorithm. Alright, given a string s, find the length of the longest substring without repeating characters. That was simple. Alright, let's look at some examples. So let me just pull my pen up here, and okay, so we have this string ABC, ABC, BB, right? So we want to find the longest substring without repeating characters, and it's worth noting that the substring actually has to be continuous. We can't just pick and choose characters as we please, so it has to be continuous. So let's just start from the beginning and see how far we can go. So we'll take this A, and then we can take the B because it's unique, we can take the C, and then we get to this A, which means that now this substring would actually have two A's, so we can't have that. So we can only go up to this C here, so that would be length 3, right? Or alternatively, we could go BCA, but unfortunately we hit a B here, so again, that's length 3. We could go CAB, and then we unfortunately get to a C, so we can't really go anymore. We could take this ABC, but we can't really do much after that because of the double B's. So we actually end up seeing that the best answer here is going to be 3. Here in this one, similar thing, we would start, okay, let's try to do PW. All right, that's fine. And then we encounter another W, so that's only length 2. And then we could try WW. No, that doesn't work. What about WK? That's fine. E, that's fine. And then we get to the W, which obviously breaks it, so we can only do WKE, which is actually our solution here, and it's 3 as well. So to solve this question, you could do one of two things. One could be to literally calculate every single possible substring and then take the lengths. That would work. You wouldn't pass the interview if you did that. Just saying, that would be a very expensive solution because you're literally defining every single one. What we want to do is we actually want to solve this in one pass through the string. So that way we can get a big O of n runtime complexity. And the way that we're going to do this is similar to how we actually did it with our example, where we were taking one character at a time and trying to add more as we go. So essentially we were using a sliding window approach. So what we're going to do is, we need to know what characters are actually in our, our sliding window. And the way that we're going to do this is, if our sliding window has characters in it, we're just going to assume that they're unique. And whenever we reach a new character, we're going to check whether or not we've actually seen that character before. So what we're going to do is we're actually going to keep a dictionary, which is going to map a letter to the last time we saw it. So we're going to say letter, and this is going to map to an index where we last saw that character. So that means that we can basically calculate our length, right? So if we are having our substring here and we're building it with the sliding window, as soon as we hit a character that's already in this kind of dictionary here, then we can basically just take the difference between where we are and where we started. So we want to keep track of like our left and our right, and we'll kind of use those to calculate the distance, aka the length of our substring. So let's see how this might work in case it's not clear. So we'll have this dictionary, and I'll just, let me put it over here to give us some more space. So what we're going to do is we're going to go character by character. So we're going to have a left pointer, which is going to start at 0. And what we're going to do is we're going to start a right pointer, and it's also going to be moving from left to right over the array, but it's going to start at 0 as well, right? So this is the 0th index. This is where we start our pointers. What we're going to do is we're going to get each character as we go along. So the first character would be A, right? So what we're going to do now is we're going to check, is this character, have we seen it before? And obviously we haven't because we just started. So we would put into our dictionary A that we last saw it at 0, right? So now what we're going to do is we are basically going to go forward, right? Because this is a valid substring. We haven't actually encountered any characters here. So what we're going to do now is just move our right forward. So now the right would move to the B. So B we haven't seen before either. So we can put B into our dictionary here, and we would continue. So now right would move forward to the C, and now we see C for the first time. So C would get added to our dictionary, and that's at index 2. So now our right will move up, and unfortunately we hit a again, right? So this is a problem because obviously in our substring we already have an A, so we can't take this new A. So now what we need to do is, okay, we're gonna check, is this character in our dictionary here, which it is, right? So what this means is that we need to double check whether or not it's actually within our substring. And the way that we're gonna check if it's in our substring is we're gonna check, okay, is the index that we last saw it, so is 0 greater than or equal to left? And left is going to represent basically the start of our substring here. So since 0 is obviously equal to 0, that means that we can't take this A because it would be part of our substring. So what we need to do is we need to update our left to basically move one character up, because now we can't take that last character. We have to remove it, given that we're now going to be taking it with the current character we're at. So in this case, when the character is in our dictionary here, and we make the check, is the character, is index, is it greater than or equal to left? If it is, then what we want to do is we want to move the left equal to whatever that index was. So we're going to say the position dictionary of our current character, which is A, right? We're going to take the position that we had before and we're going to add 1 to it because that's the new left position, right? So 0 plus 1 equals 1. So now left equals 1 and right is going to be, so this is 0, 1, 2, 3, right? So right is going to be at index 3. Now we can basically just update our maximum, so we can take the difference between the right and the left. So 3 minus 1 is obviously 2, and then we do a plus 1 because we want to have inclusive here. So we would simply say that this is 3, right? So this would be our temporary solution, and we would see if we can find anything better. And now what we want to do is, obviously we've seen another A, so we need to update the dictionary here. So instead of being 1, we've now seen it at position 3. So let me actually clean some of this up here, and actually we'll keep our dictionary, and maybe we can clean a little bit of this up here just to make it clearer for you guys. Okay, all right, that's probably fine. So we know that left, we moved left to equal 1, right equals 3, and we just finished processing. So that means that right is now going to move to the B, and remember that we already have seen a B, so we're going to do the same thing. We're going to check, okay, where did we last see the B? We saw it at 1. Is this greater than or equal to where our left pointer is? Which it is, right? Because left pointer is currently 1. So that means that we can't take this B because we would have a duplicate, right? So this represents where our substring starts. So now we need to update our left. So we now need to move it one character up. So where was the last time we saw the B? We saw a B at 1, so we would just move it 1 plus 1, right? We're going to move it 1 to the right. So now the left pointer is 2. So the left pointer becomes 2, and obviously the right pointer now is 4. And then once we finish this, it's going to be 5. So we would essentially do that for the rest of the string, and obviously we have an answer which keeps track of the biggest difference that we found so far. And remember, we calculate it as right minus left plus 1. Oops, that's kind of messy. Right minus left plus 1. And at every iteration, we want to take the maximum of this value and whatever the previous max was, right? And then at the end, we'll actually have our final solution, and that will be stored in whatever variable we choose to call it, but we can just call it previous maximum. So that's how we're going to do it. Basically leveraging this dictionary to tell us where that left pointer should be and whether or not we've actually violated the bounds. That way we can actually do it in one pass through. We only have to process all the characters once, and we don't have to generate all the possible combinations. So hopefully that makes sense on an intuition level. Now what I want to do is actually go into the code editor and type this up. The code is super simple. I think it's really clear. If you're still a little bit confused, don't worry. We're going to go into the code editor and I'll walk you through it line by line, and hopefully that should clear up any sort of confusion. All right, let's now go there and code this up. We're back in the code editor. Let's type this up. So the first thing that we want to check is actually if our string is of length 1 or less than 1, obviously then we just return the length because there's nothing for us to do, right? There's never going to be duplicates when there's only one character or no characters. So we can say if the length of s is actually less than or equal to 1, then we can just return the length of s. So pretty simple there, just a nice little edge case we can catch. Otherwise, let's define our dictionary, which is going to store, remember, a mapping from character to the index that we last saw it at. So we're going to say position dictionary is going to be an empty dictionary. And then we want to initialize some variables. So our left pointer, and we also want to initialize basically our result here, right? So we're going to say res, and these are both going to be 0 because we haven't processed anything, and obviously the left pointer starts at the beginning of the array. So what we want to do now is we're going to say for right char in enumerate s. This is just some syntactic sugar in Python to basically give us the index and the correct character at that index, which saves us from just subscripting it. So yeah, so now what we're going to do is, remember, we need to check whether or not we've actually seen this character before, and if we have seen it, we want to make sure that it's actually not in our current substring, which remember, left denotes the start of our substring. So let's do some checks. So we're going to say if char in position dict, so if it's in the position dict, and if the position dict for that character is actually greater than or equal to left, then what we want to do is that means that our string already contains the character. So that means that we need to actually move our left up to this new character. So we're going to say the left pointer is now going to be wherever we saw that character before, +1, right? So to the right of it, we're going to move our window and kind of reduce it a bit. So once that's done, now what we can do is we can actually update our answer here at every iteration. So our answer is going to be the maximum of whatever the current answer is, and the difference between, remember, right minus left +1, and that will give us the length of the current window here. So the last thing that we need to do is actually just update the position dict for our character, because we basically have now seen it at whatever index r is. So we need to actually reflect that in the position dictionary. So we're going to say position dict of of character is going to equal r. So all we need to do now is, once this for loop ends, we'll have processed the entire string, and we can simply return our result here. So where is my submit button? I seem to have lost it. There we go. Let's just run this, make sure we didn't make any syntax mistakes, and we look good, and submit it, and cool, it was accepted. All right. Okay, satisfied, go away. Let's see. So let's talk about the time and space complexity now. So time complexity wise, as you can see, all we do is we iterate through the string one time, right? So we go from right to left, and we process basically every single character. So because we're doing that, it's obviously going to be big O of n, I guess, where n is the length of the string, right? Simple enough. Space complexity wise, what we want to do here is, obviously we have this extra data structure for our position dict. So obviously this is going to be storing characters, and the amount of characters we store depends on how large s is. So this one, actually, technically, the maximum amount of characters, I believe, let's see. So English characters, digits, symbols, and spaces. So technically this is big O of 1 because you know how many letters, digits, symbols, and spaces there could possibly be. That is like a predetermined number, and since it's not based on the actual string itself, it's technically big O of 1, though you might have to say that it's big O of n because it depends on how long this is. There won't be any overwrites. Let's actually just check the official solution here. Why not? So let's see, sliding window, min, m, and n. Oh, sliding window optimized. Okay, yeah, so it is going to be big O of m. Okay, so yeah, it depends on how many characters there are. Although, okay, if it was just English characters, because the maximum you could store is 26 characters, then it would be big O of 1. But I guess we don't know what's going to be given to us, so we'll just call it big O of n, just to be safe. So there you go. That is your, runtime complexity and space complexity here. That is how you solve longest substring without repeating characters. Like I said, relatively simple one. We're using a greedy approach, only iterating over the array once, and we're good to go. So that is how you solve the question. If you enjoyed the video, please consider leaving it a like, and any random comment, really, it helps me out a ton with the YouTube algorithm. Subscription to the channel really helps this channel grow. And if you want to join a Discord community where we talk about all things FAANG, interviewing, systems design, you can have your resume reviewed by me and other peers. You can ask for referrals and all of that. If that sounds interesting to you, then please join the Discord channel. I'll leave a link in the description below. Otherwise, thank you so much for watching to the end, and have a great rest of your day. Bye.